Good morning, everyone. Myself, Nagajyothi, working as an assistant professor in Department of ECE in Marri Laxman Reddy Institute of Technology. So today, I am going to discuss about a course called as Digital Image Processing. So this course is for third year, second sem BTech students. In this, the first I'm going to discuss about what is meant by a digital image processing, what is meant by a image, how can you represent an image in a mathematical function, what is the need of studying this digital image processing, and this complete course will deal what are the different image processing techniques which we are dealing. So in this presentation, I'm going to give you an overview of what is meant by a digital image processing and the origin of digital image processing and which fields this digital image processing can be used and what are the different fundamental steps in case of an digital image processing as well as components of an digital image processing. So the first is what is meant by a digital image. So basically whenever we are capturing, so we'll be using a mobile phone or a camera to capture an image. So if we take an example of this, let me take this is an image in which this image consists of two things. One is x-axis and the other one is y-axis. So in this image, we can define an image which is nothing but a two-dimensional function in which it consists of two coordinates. One is an x coordinate and the other one is an y coordinate. So we can represent an image as a two-dimensional function and can be represented as f of x comma y. And what is this x and what is this y? So x and y are nothing but the spatial coordinates. Now let me take the same example of an image. So in this coordinates, I'm assuming that this x value is some values ranging from 0 to some finite values. Similarly, y is also partitioning some 0 to some 5 to 6 values. Now let me take, I'm assuming this is a point of an image in which if we observe that this point corresponds to a 2 on the x-axis, similarly 1 on the y-axis. Means if I want to represent this particular point in this image, this can be represented as f of 2 comma y. That itself represents each and every point in this image can be having some values. Those values are the coordinates of x as well as y. So x comma y represents the positions of that image as well as this f represents what is the amplitude, that is the what is this corresponding amplitude at this point. So in case of digital image processing, this amplitude of an image can be called it as a gray level value. So I can define a digital image as it is a two-dimensional function represented as f of x comma y, where this x comma y represents a spatial coordinates and this f represents intensity value or a gray level value at that corresponding point. So if we assume this as 2 comma 1, what is this corresponding amplitude at 2 comma 1 is called as a f, function f. Similarly, if we take the other more point, this point, so the x value is 4 and y value is in between 1 and 2. So let me assume that this is rounded off. Actually this is 1.6, but I am rounding off this 1.6 to the highest value which is nothing but 2. So this point can be written as f of 4 comma 2. So this 4 comma 2 represents where the point is in that image and this f represents what is the amplitude of this image. So if we consider a image which is of 8-bit image. Let me take, I am representing the image in an 8-bit form. So if we take it as an 8-bit image, that itself indicates I can represent this amplitude values or the gray levels ranging from 0 to 255, because the highest, that is the maximum value of 2 power 8 is 256. Always the image will start from the 0 value. That is the reason the amplitude of each and every pixel will be within the range of this 0 to 255. So depending upon the bit image, if we are taking it as a 3-bit image, so the values will be only 0 to 7. Depending upon how many bit image, the gray level values or the amplitude of that image is going to be varied. Coming to that next, what is the reason why we need to go for the digital image processing? So here the name itself indicates processing is nothing but you are performing some operations on that image. So on this image, if I am performing some operations, then it is nothing but called as an image processing. So in order to perform the processing, as the name itself indicates that it is a digital. So the image should be, this image should be converted into a digital form. So if my image is analog image or if my image is a continuous image, I need to convert this continuous image into a digital image in which it consists of only two values, that is 0 or 1. So if my gray level of that corresponding value is dark, then I am representing it as 0. If it is light, I am representing it as 1. So in order to convert this analog image or a continuous image into a digital image, I need to undergo basically 3 different steps. One is sampling, second is quantizing, and third is encoding. So here sampling is nothing but I am taking this image I am partitioning only in the x-axis, then it is nothing but called as an sampling. You are converting a continuous time signal into a discrete time values is nothing but called as an sampling. If you are dividing even the y-axis, the amplitude values are also dividing, then it is nothing but called as an quantizing. So discretizing in the amplitude values is called as an quantizing. Discretizing in the time period is nothing but called as a sampling. So if your analog image is performed sampling as well as quantizing, then that image is in the form of an digital image. So if you want to perform any operation, that is if you want to perform any operation in the image should be basically in the digital form. So as a computer can understand only the zeros and ones, a processing of digital image by means of a computer is nothing but called as a digital image processing. So basically this digital image processing is of 3 different levels. One is low level processing, middle level processing, and a high level processing. So how can we say that whether we are performing a low level processing, middle level processing, or a high level processing? So in case of a low level processing, the input as well as output both are images. So let me take, this is a image processing. If input is image as well as output is also image, then it is nothing but called as a low level processing. So if the input is image but output is attributes, means we are finding out, let me take, this is an image, this is an image. So in this image, if you see this point, at these points there is no object present. But if you observe here, there is some object present only. So if you are able to find out what are the attributes of this image, if you are going to extract the information only in terms of attributes, then such a processing is nothing but called as a middle level processing. And if you are able to recognize, means, let me take in this image, it is a combination of some fruits, some vegetables. So if I able to identify what is this image and what is this image, if I am able to distinguish between a image within that image, then it is nothing but called as an high level image. So the processing can be done in three different ways, that is low level processing, middle level processing and high level processing. In low level processing, input and output both are in the images, but whereas in case of a middle level processing, output is attributes extracted from the input image. In case of high level processing, we are able to recognize the individual objects in an image. So till now we have seen that what are the different image processing levels. So as I told you that a image is a two-dimensional in which it can be represented as f of x comma y. So the point, each point in an image is nothing but called as a pixel. So if you combine, a group of pixels will form an image. So the basic component of a digital image is a pixel. As I told you that we need to perform different operations on an image. These different operations can be performed from either pixel to pixel or on the group of a pixels. So image processing is actually a set of operations, and this image generally we are representing in a matrix form. So each and every image is represented in a matrix form, and each element of that matrix is nothing but called as a pixel. So now let me take, this is an image. So in this image, if you observe that there are different shades in an image. So some part of this image, this part is nothing but very dark, which is nothing but a black, and there are some shades of black. So this image is ranging a different shades from black color to the white color. So in this image there is a dark black, as well as there is a variations in the black as well as variations in the white. As I told you previously, if it is an 8-bit image, the gray values or the values are ranging from 0 to 255. So depending upon the color of this pixel, each pixel, here I have written the image values as 74, 75, 87, so on. So the numbering in this second figure represents the type, that is what is the amplitude or the gray level of that pixel at that particular point. The same thing I am representing in the form of rows and columns, that is, in simple words I can say that a digital image is a two-dimensional which can be represented in terms of f of x comma y in a matrix form with m rows and n columns. Always generally the image will be starting from and with origin 0 comma 0, and this f of x comma y represents the image we are representing it is in the spatial coordinates. So here x comma y represents the spatial coordinates and f represents the gray level of an image. Now coming to that, whenever we are performing some processing on the digital image, there are two main tasks which we need to focus. So the first thing is, as I told you that we are acquiring an image. Acquiring is nothing but you are taking off some pictures from using a camera. So acquiring an image. So whatever the image which has been acquired, that may be not up to the level. So the acquired image may have some blurring effect or noises, means the whatever the image which I have acquired may not be very good. So if I want to improve the performance, I need to perform processing, that is nothing but after acquisition I need to perform a pre-processing on that image. So the first focus is whatever the image which is there, that improvement of image information for people's perception and interpretation. So whatever the image which has been acquired, that image has which acquired need to be in terms of able to see by a person, that is nothing but perception as well as interpretation. As I have told you that an image can be processed, or the image is basically which in nature we are considering only a digital image. So as I have told you that the image is in digital in nature, it should be stored in the form of zeros and ones. So if the number of bits used to store the image is as less as possible, that itself indicates the memory required for the storage of an image is less. So processing of image data for storage as well as transmission and good detection of machines. So basically, whenever we are considering an image processing, the two things which we need to remember is, the first thing is whatever the image which we are considering, that should be good enough. So whatever the acquired image is not good enough, we need to perform some image enhancement techniques so that I can improvise the quality of an image. This is the first point. Coming to the second point, you need to remember, as always we are doing all these for sending information from one point to the other point. So if you are able to take less memory to store that image, that is more compatible, and you can transmit more number of images within the required memory. So as I told you that this digital image processing visions are in three different levels, but that is low level, medium level, high level. If both input and output are images, it is nothing but called as a low level. And the examples for this low level is nothing but enhancement, means improvising an image is nothing but an enhancement. So if I want to improve the quality of an image, the name itself indicates the input. The input should be an image and the output should also be an image. Median level processing is nothing but input is image, but in the output you need to extract some features of that image. So if you are giving an image in which it consists of different objects, if you are able to identify the objects present in an image, then it is nothing but called as a medium level. So the examples for the medium level processing is object recognition as well as segmentation. Segmentation is nothing but, so if an image consists of some books as well as some objects like pencils, if you are able to differentiate an image whether it is a book or a pencil, then such a type of a processing is nothing but called as a medium level processing. Coming to the third one, high level processing, if you are able to extract the features of an image, that is nothing but called as a high level processing. So this is the basic steps involved in case of an digital image processing. So in case of this, if you observe this, there are some 8 to 10 blocks. If we are able to understand the operation of each and every block, that itself indicates these are the basic steps involved in case of an digital image processing. So if you observe here, the first step is nothing but image acquisition. The name itself indicates we are acquiring, that is nothing but we are capturing an image. So in order to capture an image, basically we required of two things. One is we need to have a camera to capture an image, and whatever the camera which we are using, that consists of some sensor element which should be able to identify even a smallest portion of that. So if our sensor is having high quality, that itself indicates whatever the image which has been acquired is a good. So here in case of image acquisition, we are not performing any processing. That is, direct raw image is taken. That raw image which we have taken is nothing but called as an image acquisition. Acquiring of an image by using a sensor and a camera is nothing but called as an image acquisition. So once the image has been acquired, we need to check whether that image is a good quality image or not. So in order to improvise the quality of an image, the second step is, after image acquisition, we need to perform a step called as an image enhancement. So here enhancing is nothing but improvising the quality of an image is nothing but called as an enhancement. So in case of an enhancement, in simple words, the enhancement may be increasing the brightness or increasing the contrast. That is, and this brightness and contrast variations are varying from person to person. That is the reason image enhancement is nothing but it is subjective in nature. So from one person perception is varying from other person perception. So image enhancement is subjective in nature, which is varying from person to person. And in case of an image enhancement, we are improving the quality of an image, that is increasing the brightness or decreasing the brightness and contrast levels. All those things comes under the image enhancement. So if you observe here, the first is problem domain itself indicates we are capturing an image by using a camera, that is nothing but called as an image acquisition. So if you observe this figure, this is nothing but an sensor element. This sensor element is passed through a imaging system, and this is our image. So here what I am doing, if you observe this image, which is nothing but a continuous image. This continuous image is captured by using a camera as well as a sensor. As I told you that as it is a continuous image, I need to convert this continuous image into a digital signal in which I am discretizing in x-axis as well as discretizing in y-axis. So this continuous image, if you observe here, this can be represented in the form of a blocks. That is, we are converting this continuous image into a digital image. This is, here we have performed a process of sampling as well as quantizing. So this image is now digital image which has been acquired by a sensor. So as I told you that image enhancement is nothing but improvising the quality. If you observe this input image, in this input image, it consists of some images. In this first picture, we cannot able to identify the outer part of this, because as it is having some other, along with this original image, it also consists of some background color, so we cannot able to see it clearly. But once if you perform the operation of an image enhancement, this is after image enhancement, this is the picture. So this image, in this image you can able to clearly identify each and every object present in an image. So before, the first figure shows before image enhancement, and the this figure shows the after image enhancement. If you observe here, there is more clarity in case of the picture after the image enhancement. Basically, in case of image enhancement, this image enhancement can be done in two different domains. One is spatial domain and the second one is frequency domain. So here this image enhancement can be done either in the spatial domain or in the frequency domain. If you are performing a point to point operation, means if you are manipulating each and every pixel in an image, then it is nothing but called as a spatial domain enhancement. If you are performing a group of pixels into an image, if you are partitioning that complete image, then it is nothing but called as a frequency domain. So in case of our syllabus, the complete unit 2 deals with the image enhancement, that is spatial domain enhancement as well as a frequency domain enhancement. And the third step is nothing but image restoration. The name itself indicates you have performed an image enhancement, but whatever the image which you are having, this now you are going to transmit this image. So whenever you are transmitting this image, there may be a choice of adding some noise on that image. So that itself indicates after image enhancement, the noise is going to be added. So now an image consists of actual image followed by some noise component. So the output is not an perfect image which you have transmitted. There is some degradation, means there is some noise has been added to that image, but at the receiver side you need to retrieve back your original image. So whatever the filters which you are using to get back your original image at the receiver side is nothing but called as image restoration. So image restoration is a process in which the degraded image can be overcome and the output is similar to that of the input image. Means in case of restoration, we are removing the noise effects and the blurring effects, and we are able to get back our original image which has been transmitted. That is nothing but called as an image restoration. So if you observe this first figure, this is a transmitted image, or I can say that this is a degraded image, means this is not the actual input image. On the input image, some noise has been added to that. That output image is nothing but called as an degraded image. If you apply the different restoration filters, the output is a actual image, but this output of a restoration image may not be equivalent to the input image. So let me take f of x comma y is an input image. So for this, if a filter function is added, if I am performing in the spatial domain, this will be convolved with h of x comma y. This h of x comma y is nothing but a filter function. As I told you that there is a choice of adding some noise on that. So n of x comma y represents a noise is added. So here this is g of x comma y equal to f of x comma y convolved with h of x comma y plus n of x comma y. This g of x comma y is called as a degraded image. This degraded image has been transmitted from the transmitting end to the receiver end. At the receiver side, we are having an restoration filters by which this g of x comma y can be converted into a f cap of x comma y. This f cap of x comma y is nothing but approximated input image. Uh, Truly speaking, we won't get f of x comma y by output of image restoration, but instead of getting as f of x comma y, we'll be getting f cap of x comma y, which is nothing but approximated input image. Means the data which is present in the input image, 99% of the data will be present in the approximated input image. So if you observe these two figures, the first figure is degraded image which has been given to the input for the restoration filter. If you apply, we are having different restoration filters depending upon the knowledge which we are having. Means if we know how much amount of noise has been affected on that image and how much blurring is there on that image, will be using an inverse filter. So depending upon that amount of knowledge on the degraded image which we are using, we are having different types of filters which we are studying in case of unit 3. So by using image restoration filters, this image, degraded image, has been converted into a approximated image which is 99% equal to that of the original image. And the next one is morphological processing. So here, till the first 3 steps, we have seen that how you are going to improvise the image, and if the noise has been added to the image, how to get back that original image by using different restoration filters. So the morphological processing itself indicates that you are changing the pixel to pixel values. That is, if you are able to identify what is the change in the first pixel with that of original image to that of the present value, then it is nothing but a morphological processing. So in case of a morphological processing, we are performing a bit to bit operations, and the examples for the morphological processing are nothing but dilation, erosion, all those we are dealing in case of an unit 4. So the first unit deals with the basic concepts in case of the digital image processing, and the second unit deals with how can you improvise the image, and the third unit deals with if a noise has been added, that is, if an image has been degraded, how can you get back your original image, that is nothing but degradation and image restoration. And in case of unit 4, if you are representing an image in terms of a variations of a pixels, that is nothing but called as a morphological processing. Now coming to the segmentation. So the name itself indicates if you are able to differentiate between the segment values or the boundary values of an image, then it is nothing but called as a segmentation. So in this figure, this first part represents, this is an individual figure, but the same you are overlapping on these two cases, and if you are able to identify the first object with the second object, then it is nothing but called as a segmentation. Means you are partitioning the image depending upon the objects present in an image is nothing but called as a segmentation. And object recognition, the name itself indicates that you are in this figure, there are a triangle as well as a square as well as some circle. So if you observe this part of the figure, it consists of all the three. But if you are able to differentiate the triangle part one side, square part one side, and the circle part one side, then it is nothing but called as an object recognition. Means you can able to identify what is the different objects present in an image. If you are representing that objects in a manner which is understandable by a computer, then it is nothing but called as a representation and a description. If you are grouping of all these pixels in order to form a specific shape of a structure of an object, then it is nothing but called as a representation and description. And compression, as I have told you that as image, whatever we are performing a processing on that image, we are not storing that image only on a single device. We are going to transmit that image as well as we are going to recover that image. So how much amount of data, means the original information should be the same, but the amount of storage required to store this image should be as less as possible. Basically, you will be having two different types of compression techniques. One is lossy compression and the other one is lossless compression. So in case of lossy compression, the actual information may, some part of the information may be lost, but whereas in case of the lossless, you are not losing any information, but you are compressing the image in such a way that it can be represented in a smaller representation. And the last one is color image processing. So whatever the things which we have done till now, it represents an image only in two gray levels, that is either in terms of black or in terms of white. So if you are representing a pixel in terms of different hue and saturations, that is in terms of RGB, red, green and blue, that image if you are representing in these values, then it is called as an color image processing. Thank you.